Hi everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Vadum with Atlanta Functional Programming. Today we're going to finalize and kind of complete our exploration of cl-transducers and the transducers library by creating our own data source. This is an example that we started last week, and um, I was able to actually complete the working example shortly thereafter. So we're going to be covering that today. And this example was basically the one that we started at the end of last discussion. I'll give more details in a little bit about it. On top of that, I will mention some design tidbits that I have noticed. Probably give a few recommendations. These might end up going into issues on GitHub while I was working through this library to complete this example that I will also present to you folks. So those of you who are using the transducers library as is, it is available in Quick Lisp. Some of these functionalities may not be available to you, and I'll do a bit of a summary as what is and what is not available in the Quick Lisp distribution, so folks are aware of what uh, needs to be deployed at some point, either through a new repackaging of the cl-transducers library or, just in general extending it. Um, Before I begin, as usual, a couple of announcements. Uh, Atlanta Functional Programming is looking for speakers for folks who are been following us along. We do both online and in-person meetups in the Atlanta area generally at the ATDC, but recently we are looking for a new home. For folks who have ideas, I am available as Bugram on the Functional Programming Slack channel, as well as Atlanta's very own Tech 404 Slack workspace. So please feel free to reach out to me and provide me details as to potential venue recommendations and/or talk topics that you may want to present as part of Atlanta Functional Programming. For those of you who are outside of the Atlanta area, you can reach out to me by all means in those same venues. I also squat on the Lisp Discord server for topics both either in the Common Lisp study group that you want us to cover or a separate topic that's functional programming related that you may want to cover has a separate talk, and we will get you scheduled. Um, for What was the other announcement I was going to say? There was another thing that I wanted to mention related to AFP in general, which is, as most of you know, we have now been, going on for about 7 years now with the CL study group. I am still on the hunt for a more convenient time for folks who are in our audience who have been frequent visitors of the uh, study group itself for new times, just so that we can get more discussions going. Suggestions also for new times can be provided to me in those venues in uh, Functional Programming Slack or Tech 404 or the Lisp Discord server. Finally, if you guys like our videos and our content, please hit the subscribe button on the YouTube channel. Be part of the meetup that we have on meetup.com so we know and keep track of our members so you could get up to date information as to upcoming talks and or events. And if you have project suggestions and stuff like that, again, these communication venues that I provided would be available for you guys to reach out to me and give me those suggestions. So last time when we ended our discussion about transducers, I kind of left us with this example that we provided, where originally we had the series example that connected to a server that's on the right hand side. And in the right hand side, this is a typical socket connection. You might think of this of any streams connection from any third party library as well. And this is actually going in and just sending some information, some packet information. In this example, we're specifically sending out a just a packet that contains a number. And on the left-hand side, as you can see, we use series approach to actually go and open up the socket and using the series library, we were able to create a scanner that was able to read each packet coming in one at a time, and we threw in together a very quick series a transducer, the map function specifically, that took and parsed each packet, because again we're passing these numbers as characters to get the actual integer, and then we created a collector. You can collect sum to actually go and collect the results and give us a sum. Now, we want to do something similar in the transducers world, but we hit kind of a snag last time because of the fact that there wasn't any clear way of actually going and um, uh, being able to create what transducers considers to be a data source for it to reach out and run this transformation pipeline and eventually go out to some reducer of itself. So I had to do some digging on this. Originally, I thought it would be pretty fairly simple because a lot of the examples on the transducer source code seem to indicate it was as simple as defining a function, but it's slightly more than that. And in order to show this, I thought we'd go and look in the source code itself, and then I would provide some suggestions, and I'll show you what our final example looks like. So to begin our exploration, I thought we'd go into um, hold on a second. For some reason. Oh, sorry. Because so we'll go into the sources inside transducers to actually go look at the different types of sources that are available to us. Now, transducers already provides a series of sources for you. Data, and when I say sources, I mean data sources that will generate values for you. Okay, if you want a more complete list, you don't need to go any further than looking at the transducers.lisp package to actually look at what the def package actually provides us. Um, and this actually gives you essentially all the entry points that you can do into the transducers, and specifically what we're going to be discussing today is the actual data sources that you have. So you have the ability to cycle through a collection of values. You already have a repeater available to you. You can create random samples using um, their library already available given some sort of collection, and each of these already take a standard Lisp collection for you. All right. The one that we're going to end up modeling ourselves off of is actually ints, which is actually generating an infinite list of ints, which very much models what we would consider to be a stream socket. And so we will go ahead and leverage that to actually go and uh, experiment with our network stream example. Okay. Now, there are other stuff in here that I haven't covered as part of our series on transducers that I've been looking for examples and stuff, and then I might end up having follow-ups in here. But I just wanted to give you an update for those who are looking at this right now, wondering, well, why haven't we covered some of these things like branch, inject, and split? That's mainly because of the fact that we need to have some real-world examples that kind of really take in what it's actually talking about. Uh, so let's go and look at the ints generator, okay? The int sources. Now, a lot of these actually follow a very simple example, okay, and that is the notion of a generator object that contains a function that you end up calling every time you want a new sample coming in into your transduce pipeline that you've created earlier. And rather than creating a proper generator object using class, what the author decided to do, and I'm still not entirely sure why this is the case, he ended up creating a non-copyable um, generator struct with a built-in function. So we haven't really covered this on the study group, mainly because of the fact that um, a lot of the preferences that I've read when I was learning Common Lisp kind of pointed to the fact that you may want to use def class over def struct in a lot of cases, or if not most cases. But when I saw this, I had to do some digging into the hyperspec to kind of really understand what these are. So I thought we'd cover some examples of what the def struct code provides us, just for if you ever need to go and actually use a structure instead of creating an Uber object, you have this available to you and understand you can actually get some generated code for you for free. Now, in def struct, we've kind of talked about, well, in general, you can have this def struct with the name and you can provide a list of values associated with it. Our typical example that we actually seen is, give me a second here, is something like this: def struct, sorry, def struct point x, y, z, and this here, if you look at the thing, we can actually provide a typical object with members. So the name here, the symbol, is the name of the object that you're providing, and the remaining things are your slot descriptions. And when you generate this, you end up creating a automatic constructor for you in make point. Um, and this make point takes in keyword arguments um, that are already generated in um, XYZ, and you can actually create your objects that way, right? Now, obviously, this is pretty straightforward in most cases for structures, but there might be some things where you want to pass in a structure and then actually create a copy function for it. So it copies exact slot for slot information of the structure that you defined. And in those cases, you'd want to either write a Lisp function, or has what I'm about to point to you in your names and options, you can actually go in and specify that the copier function name, and it will actually generate one for you. So if you end up creating, if we ended up doing this again, um, and instead, and hopefully I don't get some complaints about this, doing this at this multiple times. If we do point and then we do, I believe, just copier, and then we do x, y, z, x, y, z, this would end up creating something called copy point for you, and it'll allow you to take an instance of a copy point and generate a new instance of that point. So if we ended up, reconstructing this point here, and then we call copy point on the previously returned value, you end up seeing that it will generate a new object as we expected. So this will be one memory location, as you see there, and in our copy, it's a different memory location altogether. Okay, so it could generate these copier for you, and predicates, same thing. It can actually create the equality for you to check to see, or the if a particular object instance is of this type. Um, there are many other types of initialization functions for def struct that you can leverage. In fact, def class in many ways builds on top of this to actually create its infrastructure for class. Um, I'm not going to go into too much details about that. If folks are interested, I could certainly create a stream on it, because this is a very deep dive into what was existing inside Common Lisp or in other Lisps prior to the creation of the Common Lisp object system. So there are cases where this might be better from maybe an efficiency standpoint because of Lisp implementations, differences in dealing with structs versus classes. I'm not entirely sure because I haven't actually dug into that at this time. So given that background, what this generator object really is now is nothing more than an object. It's a non-copyable object because we provide a copier as nil. You cannot check whether or not a particular instance is of this um, instance of a generator is a generator, so the predicate is also nil. The only thing it actually contains is a read-only function of this particular type. Um, which brings me to another interesting thing that discovery that I found when I was reading through this code. A lot of the stuff that you're going to see in these generator examples actually have their type signatures heavily specified. Okay, so they transducers, to its credit, actually put a lot of effort in some cases for its built-in generators to provide type hints to the compiler to generate very efficient code for generation of um, these generators. So a lot of the code that you will see will have declaim on top of it prior to the definition, and that is very useful for the compilers that support declaim to actually generate very efficient assembly code for you. So it'll optimize as much as it can. And similarly, with generators having the colon type provided for its slot, for its func slot, this is actually an additional piece of information to the type compiler so that whatever inference results it can get, it can actually use that to create optimized code. This generator is the basis of a lot of the functions that we'll end up using. And it's a very simple thing, as you can see. We're just going to really call make generator now from this. But how are we doing this and what is it? Why is it important is also something we should see. Um, the simplest one that we'll start with, like I said, is int, but there are plenty of other examples that we could go with. But this one is everybody's favorite, counter example. It creates an infinite streams of increasing numbers, um, providing that you give a negative or positive. You could also deal with the decreasing it by just making the step function to a negative number itself. But the core of this is that we end up using closures. Okay, and we've covered closures quite a bit on this stream that I don't need to bring up what they do to create essentially a closure function that's being passed into the generator constructor. All right. So what the generator actually does have is a closure that knows what the current value of the stream is at, and it will always be able to properly increment itself and then return the previously computed value very quickly. So make generator is nothing more than this simple wrapper that ends up building on top of this closure and returns us this closure. And transducers, and transduce specifically, leverages this closure to actually do a fun call on the make func to actually get the next value, and that's what's actually used to create this this transducers pipeline. They'll take in the source, be able to return a source, and so forth. Now, there are a couple things in the other functions that might become important and must be known. One is well, this is all well and good, but um, what about existing common Lisp functions that may be overridden? Because like this here is assuming that all transducer functions, whether it be reductions or the composition that actually maps the pipeline to each value, implements this sort of pipeline that assumes that we're going to end up getting the next value by calling essentially generator func um, on the object instance that's passed in. That's a good question. My understanding of the existing reducers that are already available and defined, like t colon cons. We've seen an example of that, or t colon vector that we saw in our previous example um, in here. Uh, Sorry, not in this one. It's in our transducers. Here in our series versus transducers example, our t colon vector. Um, Vector. There we go. Transducers colon vector example here. Um, each of these builds on top of this infrastructure to create a new version of those common Lisp functions for the transducers library to use this infrastructures. Okay. And this basis is what's used for actually implementing some stuff on fset. So if we were to define our own, like say, series equivalent of of this for transducers, we could certainly build that up. But then, obviously, what are we actually in this case, in the series case, we would have to ask, what exactly do we buy ourselves of creating like just scanners that actually end up being passed into transducers. It might be the case where we might want to create something a little bit more sophisticated to create stuff that then ultimately get integrated into transducers as a cooperative like extension to the library. These are the kinds of design decisions you'd want to probably think about if you're trying to like mix these two libraries. And I just kind of want to bring that up. But with this information, we can actually go and use um, the transducers generators to actually go and build our own version of this for network streams. Now, one thing about this that I want to bring up and want to do a fair warning on, and this is almost like a request, a public request to Foskers, who, if you're watching this, thanks for watching our stream on this. And that is right now, the generator object that I presented to you all is not an exported symbol in the transducers library. It could be as simple as just exporting the constructor, because that's all we really need, and then be able to pass in the lambda functions as we have as is, and then we can make proper extensions to and create our own data sources that can be passed into transducers. Um, right now, today, as it stands, the Quick Lisp library that's available, the version of transducers that's available in Quick Lisp, that is, it currently does not have this generator symbol as part of the exported API. So what I'm about to do is essentially use an unexported symbol to actually create this example, which is not a big deal for folks watching. All right, it's not a huge deal. It just means that someday if they try to remove that implementation for something else, our code is automatically broken. But you should know that ahead of time, because surprise, surprise, that's the cost of creating and using something that is not exported, right? You're using it at your own risk, all right? So be aware of that. I'm proposing that this should be part of the public API. I might end up writing an issue on GitHub for this, just because I feel like this will then allow quicker adoption, more sources, more active development for third-party libraries to leverage and be hooked into this transducers framework. And it will allow folks to really push the limits of the design of the library itself. So let's go back to our example. Okay. So with this, how would we end up leveraging this infrastructure to actually go in and write this? So I've created an example of this already that we'll start, and then we'll adjust it to match what we have in the series example, and then we'll do some comparison of it. Instead of collect sum, what I'm doing here is I'm just really grabbing all the results here. Okay, so this is similar in sense, but it's not a true reduction. Okay, I could certainly just change this to plus, and it'll be exactly the same. But I just this example that you're seeing is just what something I came up with shortly before our stream, just to see how this would pan out. Um, but let me just switch this up just for our case. Okay, so now both the collect sum and our transducer example both match. We need to actually load this into our Lisp, because I just restarted our Lisp. Okay, I'll go ahead and do that. MCL load. Okay, loaded all of our stuff. Let's go ahead and load up our examples. And then we need to first start the server. But before we start the server, to give you a quick demo of how this all works, notice the code in this piece here and in the earlier example. Let me try to see if I can get this side by side. Is let me try. Let me see if I can do this. Okay, this is close enough. All right. All we are doing in this case, in our series example, is with the open socket, we're calling collect sum, and then we're creating our simple scan pipeline. Whereas with our transducers example here, we're in control over the um, the pipeline to what our sample size is going to be here. Uh, I can make this the same as something else. Like right now, this is saying take 1000, but this really doesn't need to be taking 1000 because we are in both cases matching, getting the full socket stream, which is 1000 samples of data. But I wanted to show you, at least with the transducers pipeline, that you can add whatever you had before. So let me just go ahead and do that because I don't think this is necessary. Delete that. Okay. Load that up. So that's compiled and everything's good. All right. But so now the code is exactly the same in both situations. All right. The only difference is here we're providing um, our transform to being containing a single map function that's called parse integer. Obviously, it could be something else. Um, but you need to create comp for this pipeline in order just to understand the functions that it's creating. In fact, I think we'll try some optimizations to clean this up, but this is kind of matching the same infrastructure that we had before. So without further ado, let me just do this and let me load up another Lisp image. And I have our Lisp image that already has our code here, um, the server code running. So I just need to start up the Lisp image here. And now I could go here and run our transduce client example. And you can see that, oops, did I mess something up here? No, 0. Oh, that's because it didn't, okay, got it. 1 second. Uh, it looks like it didn't, oh, all right, damn it. Okay, so I accidentally, uh, do this. Can I? Okay, let me do this, and then let me load this guy in our socket. Okay, let's try that again. Server main. Okay. Earlier I was. Ooh, hold on. Socket address and use. Um, let me quit this. Hold on 1 second. May have to create this because it's a dead process right now. Just 1 moment here. Um, okay, start a new one. Okay, go here, go up, and let's try just changing the port because there's a dead hanging process right now um, that that I need to first clean up on the backside by killing um, the Lisp code differently through the terminal that I'll deal with after our stream. Let me go and load this up. Basic server. Okay, so now this is it. Actually, go here. Okay. Server main. Okay. Let me change this guy up. Fortunately, I'm gonna have to because right now Let me see if I could do set default connection here. Slide default connection. No, it's not coming up. Okay. Unfortunately, right now it's my Emacs buffers are now pointing to the basic server REPL, and there's a specific command that I'm forgetting off the top of my head to actually go in and uh, make this buffer attached to this Lisp REPL because I'm working with multiple REPLs right now. So without uh, bumbling along, I'm just going to redefine the transducers example this way by just copying and pasting it. If I run this now, what happens is, wait, condition on end of file stream is unknown. Wait a second. Error no 0. Okay. What is... Okay, it's the same problem that we had earlier. Let me do this. Maybe it's not liking the fact that... Hold on. Let me do this. Signaled. Okay, so I'm gonna have to also deal with that. Give me a second here. This is... Oops. Sorry, I killed all my Lisps. But that's fine. Let's do this, do that. Okay. And let's change this guy because I'm trying to clear up all the examples that we're getting. The problem might be because I can't map integers directly from it, but I have to actually take samples from the file stream. This is just probably the way transducers work. Okay, give me a sec. Let's do this. This is kind of a quick experiment that I didn't expect would to work the way it did. Kind of expected something's different. Okay. Start a new one. Okay. Load that in. And that. Okay. So let's do something slightly different here. We're going to do t vector just to see what we had before. Okay. Okay, compile and loaded. Let's do this. See that? Okay. So this is now working. Let me switch this up. If I do plus, we run this again. Now, oh, it's because it closed it. Got it. I have to restart the server because I didn't actually make this on an infinite loop for each connection accepted. I should have done that, but um, that's let me switch over to a different example. Oops, sorry, wrong Lisp. I have to go to this one. Start the server, and it's not closing the socket. Huh. Interesting. It should have closed the socket, and it's not closing it. Address in use error was signaled. Oh, got it. Got it, got it, got it, got it, got it. I made a boo-boo in my server. I forgot to add reuse address as being a possibility. Okay. Um, not a give me a second. I'm gonna have to kill one of my Lisps. Well, I'll kill both of my Lisps. Let me quit both of these here. Quit Lisp because it's not going to work any other way. Okay. Um, this one and go here. I have to use listen args. Reuse address should be true. I think it's this one, like that. Okay. Okay, so let us do one thing because I just realized I accidentally put this in our previous buffer. That's not what I want to do. Start another one. Okay. Okay. Let's see. Go back to this. Start it. Okay, let's run this one more time. Okay, so because I realized that I didn't also, there we go. Okay, so reuse at least works, but I have to also add the loop so that it'll keep on accepting connections. I didn't want to add the things because I wanted it to close and clean itself up correctly before, for the sake of this example, but clearly I should have actually written a little bit more robust situation for our examples. But okay. So this is actually kind of working kind of somewhat as I expected. The server interaction is still somewhat shoddy, but the example still kind of provides itself the same notion. Um, let's go and check to see this compared to our client example. Oh, dang it. Um, okay, one second. I'll just go ahead and do this too as well. Uh, where are you? Um, unwind protect. I think if I remember correctly, I have to do this. And if I just run loop, that should be it. Okay. Uh, okay. Okay. And then switch to this. Run this guy. This is there. Run series. There you go. So if you look at the difference between this one and the other one is we're missing actually one sample in the transduced client example versus our series example, and that can be seen by looking at what is being returned for in series versus transduce. Okay, this is one difference I did see last night that I was a little surprised about that I thought we'd cover today. Now, an intriguing I would probably already know what what this is. In one case, we are essentially doing inclusive. The last sample is actually correctly. We're doing a half open interval versus closed interval, but I wasn't sure I was like, let's go and just, grab simpler examples, run, sub-series on top of it, get the first 10 examples and see what we get. So I thought we let's go do that on the live stream and just see what the inclusiveness is. Okay. Um, Before we do that, are there any questions with the design, the general design of this? Bec- okay, give me just 1 second. For noobs that are on the channel, yes, welcome to the Common Lisp Study Group. As the title says, yes, this example is using the cl-transducers library, which is very much it's a closure library that's been ported into Common Lisp. And we're doing kind of a compare and contrast between this library and another library that provides functional style programming, that is the series library, which is we've already covered in the past. All right, so in order for us to do this, we're going to have to write another example. I'm just going to go ahead and write this straight up here. And this is going to first take our scan stream, which we saw here, that requires us to provide read line. All right, scan stream. Oh, wait, I need to first do this. S with client socket. Oh, sorry, not S. US with client socket for usocket. And remember, our client socket is requiring us to do what now? Well, let me just go grab these two things here. We need to grab the stream and the port number. Um, so here we go. Okay, and let's go ahead and add this here. And in here, we now go and we're going to use the same. I think I have to use, yeah, I have to use unwind protect. I have to use unwind protect. Unwind protect. Okay, make sure we properly close the socket. Okay. There is some boilerplate here. We could clean this up a little bit ourselves, but I will put that on in due time. Uh, let's see. We do now do S. I think it's collect list. What is this? For some reason, it's not recognizing my local nicknames for series. I'm wondering. Okay, that's the reason why. It's because of the fact that it's still tied into um, the other example. Okay, so give me a second. I'm gonna have to stop the other server because I want to be able to wait, one. Okay. Again, this has been a little frustration of mine. I have to figure this one out just because switching between different lists in different buffers, attaching them to different things has been a little bit of a pain point when I'm working with different Lisp images, which is what we're doing here. Effectively, we're working with different applications. Um, but this is, I know that Sylvester and Slime itself provides the ability to do this. I just haven't had a chance to go and um, get into the habit of actually using those commands on a daily basis, because usually I'm working with one Lisp image when I'm playing around with stuff. Um, okay. So first things first, we're going to start the server again because we're done with the server, but we just need to um, have it be started before our transducer example, so that in Sylvester it makes our transducers examples REPL the default connection in Slink. So it makes sure that the Slink connection is the same. There again, folks watching, user manual has some way of doing this. I just haven't spent time actually digging into what the exact commands are for this. So let's do this. Start up our server. Done. Okay. This is no longer going to be in our involvement anymore. This is just our data pipeline. You could think of this. Okay. Now we're going to start another Lisp image. Fire up our code in, whoops, unknown decondition. Okay. Let me see what happened here. Please tell me this didn't stop. Sorry. Go to this one. Unknown error. Shoot. This is going to now have address and reuses in it. Nope, it doesn't. Okay, cleaned it up. Okay. Hold on a second. This. Try this again. Okay. Let's go down to this. And excuse me. So what was I trying to do? Yeah. So what we do here is we have s ooh, still not completing itself. Restart. Hold on one second. Do this one more time. Okay, and do this here. Okay, and switch it to into this examples, because now we have our things, and now we could do this. Okay. We're going to do collect to get our collectors, and we're going to create collect list. I guess would probably be the easiest one. Hold on. Why is I had thought there so there are different collectors for this, but my assumption that there was a connection for Lisp was available was wrong. Let's see here. Um, we could create our own collecting function, but I'd rather not. Let me see if I could do uh, alias. No. Let me see if collect would actually allow us to do this. Um, and what we want to do is run scan stream on the stream using readline. Okay, and what we want to also do is we want to grab the integers, like we did before. I mean, it doesn't really matter because we're going to be looking at just their string values, but hold on. Okay, but this is kind of useful for us, which we've done. It's a sf map. It's map function, right? Yeah, it's map function. Let's just go ahead and grab this guy since we did already done this before. Okay, so let's see what this returns us. We're gonna probably have to do this cpwr print, then do this to reformat everything. Okay, and let's run this example and see what we get. Okay, so in this example we got 10,000 integers. Okay, um, now unfortunately transduce doesn't ellipse. It has a built-in functionality that we saw earlier, that it just returns that we'd want to actually get the full collection spit out. So let's change this here to add just the first 10 samples, okay? Okay, so to do that, we just do here scan stream, then do s subseries, okay, and then we're gonna get the first 10 samples, or first 20 samples, just for the sake of making things a little interesting. Okay, so we now have this. Let's go and run this. Okay, so we have 0 through 19 here. Wait, what is it complaining about? Oh, error connections refused because we've actually killed it. Let me go to, sorry, there we go. Go to SBCL, run this because of the unknown error, which I have to figure out at some point. And let's go to, sorry, this guy. Okay. Shift D, clear REPL. Okay. So this is our example. Couldn't write to um, okay. This is happening a little bit more frequently than I thought it would. I have to look into this. This is something dealing with the interaction with the USocket that we're not getting when we're running it as is within the concept of the function. But if you're running it inside just a REPL as is, um, it's doing something a little bit more different than it's expecting. So I will have to dig into that. But with series, you could see that we're getting 0 to 19 complex examples here. If we run the same thing, let's see, with transducers, let's see what happens. Okay, again, I'm going to have to follow the same example. I'm just going to copy the stuff that we did earlier for generating all this, because this is the same stuff that we'd have to do to grab what we need. And we're going to have to do in here, here. Okay. Okay. So now do an unwind protect. Make sure that we socket close our connection. And put that up there, and we do cl-transduce our sample is going to be t-map parse integer t-take 20. Okay. Our reduction function is collecting the results into a vector, and our generator is what we are seeing here. So what does this do? Okay, it didn't actually print out what I expected it to. I thought it would actually print this out. Let's see what it does here. And we see the same thing. Huh. Why did it then provide the reduction? It seems like a bug. I think I may have encountered a bug here in Mr. Integer Transducers library, because it's giving me both the inclusive stuff. Let's change this here a little bit. Let's do let's make this into 20. They should be identical then if they're, or not even 20, let's do 10. Okay, because we all know that the first 10 integer sum is 55. All right, so we're expecting 55 to be both in um, these examples. Here I'm going to have to also do 10. So do okay, and run this. Okay, so run the series example first, and oh, because we aborted the server. 1 second, I have to restart the server because it got aborted. Run this. Okay, switch over to this. Okay, our series example number 45. And if I try to run this again, I'm going to end up getting the same problem. Hold on. I'm going to have to restart the server because it's killing the server, surprisingly. I don't think it currently likes the way I've written the server. It wants me to be a little bit more robust once I reuse the server, reuse the address the way I did. There's probably a quick way of handling that. Do this. Let me see if I could do. doesn't like the fact that I want to split the window on the Lisp REPL. That's a little frustrating. Um, okay, I'll take care of that in a separate discussion. Let me go back to just restarting the server here, and let's see what happens when I run the transducers example. They're both 45, 45, and yet in one case I ended up getting 49,000. I was off by 100. I'm sorry. I was off by something in the transduce example earlier. That's weird. So let me just do this one more time. Maybe this was just a consequence of the way I've written something. Actually, do this, do that. Then let me change this to back to 1,000. Okay. Let me just quickly do this. If I'm going to constantly having to restart the server, this is kind of useless. This yoink paste. Okay. Let's do this. Series. Huh. This is really weird. It's the sample that it's missing is the last is the 1,000 in this case. So, oh, got it. That's right. It is doing the right thing. In transducers, it's half open to as well. So it's getting the first 999,000 samples. I have to get it's 0 to 100. So the last number it's getting 999. It's not getting 1,000. Whereas the other one is actually inclusive. So it's going and getting all the 10 samples that we expected. Because it's getting the entire stream. So we're dropping a packet here. This here should not work, but I'm betting it's going to work because we ignore the last value. We ignore the last value in there. That's a little odd, but okay, fine. That's okay. And the reason why I say that's a little odd is for folks looking at this, you would think that you're getting 1,000 samples, right? Actually 1,001 samples in both cases. In the first one,
But Rom,
oh no, okay, never mind. In the first one, we're actually grabbing the entire stream, and in the second one, I'm ignoring the last packet because I'm actually taking the stream and grabbing the first 1,000. I mean, okay,
is it odd or even?
huh?
Just kidding.
It's a little inside joke, folks. It's a little inside joke. All right. Um. Okay. So we now grabbed all the all the samples that are coming off the stream, and then um, uh, we're summing it up in both situations. So we're getting exactly the same stuff now. Um. Interesting. Okay. All right. So to summarize what we've done here is to write your own data sources for transducers, you have to create a generator function. This is not a suggestion. because I tried the other day to create like this infrastructure separate from what transducers wanted, just to see if structurally is the same, it should actually go through the pipeline no problem, right? No, it is looking for um, the symbols to be identical because the types have to all match up, right? And so because of that, even if you did create something similar with the same type signatures, since internally the symbols will be different, it actually ignores that and says that generator does not have this particular function. It throws some sort of condition. So we don't do structural equivalence here. All right. My suggestion, the workaround is use this generator object and Foskers again. If you're listening, go ahead and make an export function, be done with it. Because I think a lot of folks could then attach a lot of different data sources into transducers and do what they want. Um, I was actually thinking to see if I can use this to like hook into Mongo or other data sources too as well to create like data pipelines to do different kinds of transformations because um, you could do the same thing in series pretty quickly, but for folks coming in from closure, this is much cleaner, certainly, and especially given the fact that in series, the transducers logic requires you to essentially define your pipeline has a series of essentially function calls because like here we have our collector, we can read this as if we're reading code. We're creating a scanner, we're mapping each value into the stream, and then we're collecting the sum. It's kind of nice to have this composition syntax, which I'm and creating like essentially what something needs to be applied for every value of the stream. Now, I'm not saying that you can't do the same thing here in the series world. The difference is you're going to have to write your composition ahead of time before interacting with series. Whereas here, everything is kind of upfront in this mini structure to transduce. Okay, so there are some preferences, some stylistic preferences between the two, but fundamentally they're doing the same thing in terms of composition and interacting with each value ahead of time in this map reduce style um, framework. So that's it with transducers. Um, Expected this to take a little longer than I was in. I'm going to open the floor to a discussion um, to see if there are any questions. Uh, Next time, we're going to actually start doing kind of a quick review of where we are right now, mainly because in order for us to dive into paradigms of artificial intelligence programming, which is our next series, we need to cover the first three chapters. I want everybody to know what Norvig actually thought of at that time when he wrote Paradigms of Artificial Intelligence Programming to set the stage for when we write early AI programs. Um, those of you who have already read some of this material probably are aware that that book wasn't designed to be read cover to cover. It was designed to have almost like a combination of three different courses. One being an introduction to Common Lisp for folks who haven't touched Common Lisp. Two, it was also designed as a course in advanced Lisp programming because it deals with issues of efficiency, and it uh, teaches you all. It's a survey course in artificial intelligence, so it goes through standard early classical AI programs such as planning, expert systems, first order predicate logic. It goes through some basics of natural language processing and eventually machine learning, which we'll then dive in a little bit deeper into with in recent developments with deep learning and transformer architectures. Now, folks coming in, if you're thinking that that book is going to cover transformer architectures, you are severely mistaken. That book was written in the 80s, early 90s. Transformers came out in the early 2000s. So, but it's important to read it mainly because one, it is a testament to the software engineering practices that are still required to adopt if you're using Common Lisp seriously for your large scale programs. And additionally, you don't make the same mistakes when you're adopting transformer architectures for your own use cases, like thinking that you might be able to use expert like systems. You're going to have to do something slightly different to make sure that those kind of uh, use cases fit into this ML paradigm slightly differently. I am planning on covering all of that and more as we go through it because it is a topic that I'm heavily interested in, amongst other things. But it's more of an like real artificial intelligence, folks, and I have my own opinions on what I consider to be real artificial intelligence. It fits into um, what a lot of earlier pioneers, not to mention recent uh, delvers like John Carmack coming in, and that is AI is AGI. When most people talk about AI these days, they're just talking about machine learning as is. But that's a different discussion for a different day. That's it for today. Are there questions?
No, I'm cool. Thank you very much for the distinguishing between, series and transformers or transducers. That was good.
Great, thank you. Um, I will just tell people next week we're going to be beginning our journey in AI. Between now and then, if you can grab a copy of Paradigms of Artificial Intelligence Programming, do so. That book has exercises that we're going to be covering too as well. Um, I'm not going to cover the material in depth, mainly because of the fact that I want you to read the book. I think most people should read that book. It's a great book. A lot of Norvik's material on artificial intelligence, even to date, I constantly go back and reference it. And my recommendations, if you never touched the subject of AI, on top of Paradigms of Artificial Intelligence, I do encourage you to look at his book with Stuart Russell, Artificial Intelligence: A Modern Approach, which also covers the same material on top of some other stuff. And as we go on, if there are machine learning suggestions and machine learning books, by all means, folks who want to reach out and hand them off to me, I'd love to read those too as well. Write comments in this uh, video if you like, and obviously, if you like our content, please subscribe to our channel so that you could get updates and new upcoming videos. Thank you for joining us. I'll see you next week.